We now demonstrate how to use a LIProxy tool to simulate high detection of pulses, of optical pulses from lining. We have to put MATLAB in the directory where there is the folder amending all the code that we have developed. First of all, we have to add the directory as folder and subfolder to MATLAB path. After that, we go inside source code and drag new underscore GUI.m within the shell for command. And immediately the GUI will blow up. We have several possibilities to make LIProxy tool run. We will now show how to simulate the presence of optical pulses coming from linings driven by seviri images. Seviri images have to be uploaded to the folder of LIProxy tool as HREAD format and to put it within HREAD reader folder as a folder with the name of the day, and within that folder the slot that we want to use. Within the slot a couple of folder, one with all underscore in the name with the epilogue and prologue of the image as they come from Humetstat, and the other is the infrared 10.8 channel image that we will use to drive the presence and the position of the lining pulses. So if we want to run LIProxy tool on another day or another hour and minutes, we have first to download HREAD files and put within that directory. Turning to the GUI, we now know that we have the availability of 2011, September the 12th at noon. So we put all the values. We are supposed to put also the end time values with the ending of the simulation. We have to choose all the fields instead of the fact that they have already the desired value. For example, if I desire here 0, I need anyway to touch the value and write 0. Otherwise, MATLAB doesn't recognize the value I have inserted. And then for storm simulation, simply click on seviri and process. This will take a while. First of all, the LIProxy tool reads the HREAD files from 10.8. It individuates which pixels have a temperature that is a proxy for deep convection, so really cold temperature, and it resembles the MSG position to the position of the pixel in Li matrix. Then, randomly, the program chooses among these pixels some candidates and it produces an optical pulse with the position of those candidates chosen. It may take a bit, just to wait a few seconds. Okay, so the processing is completed. The program has produced more than 10,000 pulses with the triggering of more than 13,000 events at the LE matrix level. If we want to show something, we could go to the plotting section, leaving as start time and end time default, that they correspond to the start time and end time of the simulation, and we choose to plot events and pulses. With the seviri run of the program, there is no production of photons, and we push plot. This may take a while, it depends on your computer. We are just now running on a 4 gigabyte 4 core Lenovo laptop, and that's it. So this is the screenshot of the whole quarter of hour simulation. If we zoom to an area, we may notice clusters of events around the intense lining presence. The green circles represents the pulse position, while the red square represents the events at the matrix level. It's interesting to notice that for some pulses we may not have any event triggered at the LE matrix level, while on some big pulses, this is only the central position, but there is a spread out of light all around, we may have the triggering of pixels that doesn't see the direct presence of a lining there. With the right click, we could reset to original view and describe the fact that there is a time trend graph of the events here below, while during the simulation we permanently represents a fixed number of pulses. This is predetermined within the code with a reasonable number, while the events number, it may oscillate depending on the empirical and functions and the random number generator within the MATLAB code. If we put here in delta t a value, for example, of 60 seconds, we could use this delta t to bring back the end time for the plotting, or to go forward with the start time of the plotting, just to reduce the amount of values that we want to represent on the scene and having more rapidly the depicted values